It's the scratch out. Scratch out. It's the scratch out. Tyson scratch out. Hey everybody, welcome to another edition of Tyson Scratch Out. Well, not really scratching scratch outs again. I'm doing math again, and I'm going back to the 0.99 repeating equals 1. You know what I'm saying? People still don't, they don't want to believe me, nothing I say. So I had to dig deeper and show some things. So first off, to see whether this is equal to 1, we got to see if something is greater than that, then this is not equal to 1, because it's not even equal to that. Because if this is greater than that, then 0.999 repeating is not equal to 1. So in order to do that, I'm just going to show a couple of things. And first off, I'm just going to show the infinite series for each one. Okay, so here you got the point F repeating is like 15 over 16. This is hexadecimal, so the base is 16. Then, you square each one, each term of the series. And then the 0.9 repeating, you got the base 10, and you multiply by 10, multiply by the base each time, not square each time, but multiply by the base. And then that gives you that. So this is 0.99 and this is what's 9. So some might say, okay, that they still equal each other. They tell me they equal each other later on, even though this is like greater than that and this is greater than that again. It is greater than that. I don't know. They just, each term is greater, as you can see. And it goes on that way too. You know what I'm saying? It's greater that way. So I don't even know why they even question. Again, they question that. So, okay. But anyway, we're gonna look at this. Okay, this is like 0.99 in base 16. You know what I'm saying? It don't even start with the 15. Then it ain't got a 15 here, but okay, it does start to grow as you go this way. Keep going, it grows. But I don't know, does it grow fast enough? It's like, let's look at what these numbers are doing. Okay, it starts out a little lower than 15. It's not 15 over 16 because the other one, okay, it's not 15 over 16. Comparing them, it's a little less, but people might say, okay, well, you see how these bigger? These are bigger than that 15, so it catches back up. And I'm like, okay, yeah. You can believe that if you want to, but I don't. But okay, anyway. Now I'm gonna show you like the first 5 partial sums of each one compared. You know what I'm saying? Okay, so the F goes like this. Is 0.9375, and then it's, you go down, it's like a bunch of 9s get added. But okay, 9 goes like this. I guess I should have did this one first. See, 9 goes like that. It just go 0.9, 0.99, 0.99, 3 9s, 4 9, and then I forgot a 9. Excuse me. I knew I was gonna do something crazy. But anyway, I'll let you look at that right there. Forgot a 9. Okay. So anyway, you got these 9s, and we're gonna put this beside it. Okay, as you can see, the first one is just a 9, but then it's extra 375 over here to the right of that 9. And okay, then the next term is like, it's an extra 609,375. Well, it ain't 600, but it's an extra 6 numbers over here. But it starts with like 6 to 1,000. This is the hundreds place. It's 1,000, 6,000 more. Then it's 7 10,000s more. Then here it's 100,000 more. Then even here it's a whole 9. So let me see, 1 2 3 4 5 6. It's an extra 9. That's 5 9. This is already 6 9. So it's already greater than the 6th term of that one, the 6th partial sum. I'm sorry, 6 partial sums of this one. So anyway, but people still claiming, okay, the 9 starts growing and it catches up to the point FF repeating. And I just don't believe it. I'm just saying, you know, you can see that this one is just greater. Okay. That just my analysis right there. So right here, you can say, is this greater? Yes, I can say yes, confidently. Yes. So if this is greater than that, this is not greater than 1. You know what I'm saying? This is not 1, because 1 is in hexadecimal is 1.0. And point F is F repeating is smaller. So this is not 1. It's either equal to 1 or it's less than 1. It's almost 1. You know what I'm saying? Like this one, people were saying was 1, but it's not. It's less than this one. So this one ain't even 1. You know what I'm saying? Whatever. But okay. That answers the first question. Now, and the second, my bad. No. See, it answers that one question too. Okay. But anyway, I'm just gonna show you how far they are from 1 when you take the partial sums, okay? 0.99 is 0.1 away on the first one, you know what I'm saying? Then this one is that far, that far away. So it's closer to 1 than this one. Then right here, this is 1 100th, and this is 3 1,000ths away. So it's just like these numbers. You see how this gets super close here, and this one ain't even trying to do nothing yet. It's like way here, and then for this one to get there, it's gonna, let me see, 1 2 3 4 5 6 7 8 zeros. For this to have 8 zeros, this is 2. So this is have to be 9. The 9th one would be like 8, well, it'll have 1 2 3 4 8 zeros, but it'll be closer than that then. But by the time this is 8 zeros, imagine how far it'll be. So in conclusion, the conclusion is point FF has an infinite amount of numbers between it and 1. You know what I'm saying? Just like 0.99 repeating does. And people didn't want to accept that because they want to say, okay, base 10, you can't get nothing greater than 0.9 repeating because it's all 9s. Well, all of them will be all 9s if you work in base 10. But if you work in another base, like the base above, or like I went to base, 16 or hexadecimal, and and it just show you how closer 15 over 16 is, which is F in hexadecimal. But if you go up to, a base 101, and then you start out with 100 divided by 101, you know what I'm saying? You get even, you kill this number again, you know what I'm saying? It's just like, no matter how close it is to 1 or appears to be, you can always go, what's the name? You go greater. They act like that's what, like, them numbers equal, and I didn't like that. And I just like to thank all y'all for tuning in to another edition of Tyson Scratch Out. And in conclusion, no, it's not equal to 1, and yes, this is greater than that. So yes. All right. Thank you, everybody. Have a good day.